another Leetcode problem 779, case symbol in grammar. So the idea is that we are giving a number n and a value k. So if n equals to 1, so we have a 0, it's going to be here. Yeah, so if n equals to 2, so we're going to have a 0, and this 0 going to become a 0, 1. So if n equals to 3, so the first row, the second row, and for the third row, so 0 going to be always be 0, 1, and 1 going to be 1, 0. Yeah. So if n equals to 4, let's just check. So the 0 going to become 0, 1, and 1 become 1, 0, and this one become 1, 0, and the 0 become 0, 1. Yeah, let's just write another row. Maybe we can find some intuition about it. So for 0, we're going to have 0, 1, and for 1, we have 1, 0, 1, 0, and this 0 going to be 0, 1, and this 1 going to be 1, 0, and 0, 1, and 0, 1, and 1, 0. Now let's just check the fifth row. So for this row, let's split it into two parts. Yeah. So from the left side, we can see that is 0, 1, 1, 0, 1, 0, 0, 1. It's exactly the same as the previous row. This is 0, 1, 1, 0, 1, 0, 0, 1. Yeah. Now let's just check the left part for the previous row. It is 0, 1, 1, 0. It's exactly like the previous row. 0, 1, 1, 0. Now let's just check this part. The third row, the left part, 0, 1, it's exactly like the previous row. Yeah, so this means if we need to find a value of n and k, so if n and k is at the left side, we can always find it. So for example, this is n0, n equal to 5, this is nk, n equal to 5 and k equal to 4. So the fifth row and the fourth number is going to be 0. How can we find it? So we can directly go to the fourth row. So it's going to be here. So it is a 0. It's exactly the same. Yeah. So what about this 0? Because it is at the left side. So we can directly go to the previous row. So it's going to be this 0. Yeah. Now what happens if this 0 goes to the right side? As you can see, it goes to the third row and it is at the right side. Also, it's really clear. As you can see, this is 0, 1 and this is 0, 1. But at the right side, it is 1, 0. It means it is the flip of the previous row. So the previous row is 0, 1. At the right side, the right part, going to be a flip of the previous row. So 0, 1 is going to become 1, 0. And this is 1, 0. And similarly for here, 1, 0, 0, 1. It's going to be the flip of the previous row. So this is 1, 0, 0, 1, 0, 1, 0, 1, and this is 0, 1, 0, 1. It's going to be 1, 0. As you can see, it is the flip. So if it is exactly like that, basically it means we can solve it by using DFS. It's going to be log n time. So n is the depth of the recursive function. So n going to be 30. Yeah, so the time complexity is going to be 30. It is a log 2 to the power of 30. Yeah, so this means while we are using the recursive function, we can always find the left part or the right part. And then we can always go to the left part or the right part. Finally, we can always find an answer, whether it's going to be 0 or 1. Yeah, now I think we can solve it easily. For the left part, it is okay. But what about if we go to the right part? If we go to the right part, we just use a flip. So for any value, for example, it is a 0, we just use XOR to flip it. Yeah. So, so for example, if the value is if we find a value which is a 0, so 0 XOR maybe with 1. Yeah, so we're gonna flip it with 1. So it's gonna be 1. Yeah, so 0 flip XOR with a 0, it's gonna be 0. Yeah. So now let's just use this kind of idea to solve the problem. So we're gonna define a DFS and gonna be starting from nk, and we're gonna check if it is the first row. So we're gonna return a 0. So this is according to the first example. Now we're gonna check the value of k. We're gonna check if k is at the left side or at the right half. If it is at the left side, basically this means k should be less than or equal to 2 to the power of n minus 1. So for example, if n equals to 2, 2 to the power of n minus 1 gonna be equal to 2. If n equal to 3, for example, 2 to the power of n minus 1 gonna be equal to 4. Yeah. If n equal to 3, basically this means 0, 0, 1, and 0, 1, 1, 0. This is for n equal to 3. Yeah, so the length of the row gonna be 4, but we need to take the left part or the right part. Yeah, so it means we need to divide it by 2. Yeah, so this means if k is less than or equal to this value, it means it is at the left side. So we're gonna use the DFS to the previous row, and the value gonna be k's value. Yeah, we can directly check that. Otherwise, this means k gonna be more than this value, so it means we're gonna go to the right side. Yeah, so if we go to the right side, so this value k gonna minus this value, minus the left part. Yeah, so this is gonna be the left part. Yeah, but this value, if it is a 0, we're gonna turn it to 1. If it is 1, we're gonna turn it to 0. So we can use XOR with 1. So 0 XOR 1, so it's gonna become a 1. 1 XOR 1, it's gonna become 0. So this is why we're gonna use the XOR. So finally, we just need to return and okay. Yeah. So this is the left half, and this is the right half. So no matter if it goes to the left or right, we can always use the recursive function until this n equal to 1. If n equal to 1, we're gonna return 0, but it depended on there is a XOR with 1 or not. If there is XOR with 1, so we're gonna return 1. 0 with 1, we're gonna return 1. If there's no, we're gonna return a 0. Yeah. As you can see the result, the final result gonna be 0 or 1. It can only have two cases, 0 or 1. Yeah. Now let me just run it to check. As you can see, it works. Now let me just submit it. As you can see, it passed all testing cases, and it's pretty fast. Now let's just have a review. So the idea is that we're gonna check each of the row, and then we find some intuition, because definitely for each of them it's gonna be 0, 1, or 1, 0, and then we find if it is the left side, it is always the same as the previous row. If it is the right side, it is always the flip of the previous row. So according to this idea, we can write the recursive function and solve the problem. Thank you for watching. See you next time.